Friends, good morning. In my previous lecture, I had started with the protection of induction motor. I had explained that there are two basic protections. One is short circuit protection and second is overload protection. I had started with the overload protection. In overload protection, there are two types of protections. One, current sensing. They are called as current sensing protective devices. And second is temperature sensing. They are called as temperature sensing protective devices. I had explained overload protective devices based on current magnitude. So basically it is thermal overload relay or IDMT relay or extremely inverse characteristic relay. Extremely inverse characteristic relay is preferred because it matches with the heating characteristic of the machine. Then I had explained how this relay characteristic is matched with the heating characteristic of the machine as well as starting characteristic of the machine. In this video lecture, I will explain short circuit protective devices. Short circuit protective devices SCPD. For very large induction motor, that is 1500 horsepower and above, percentage differential relay is used for short circuit protection. This percentage differential relay is installed in the same way as it is installed for the generator protection. Operating principle is same, so it is exactly same way it is used for the generator protection. This I had explained in the generator protection, so I am not going to repeat it. Second, for large induction motors. For large induction motors, it is high phase instantaneous relays that I will explain in this lecture. For small induction motor, it is fuse, MCB and MCCB. MCB is miniature circuit breaker and MCCB is molded case circuit breaker. So I will explain large induction motor protection, that is by high set instantaneous relay, and small induction motor using fuse, MCB and MCCB in this video lecture. Now this is the scheme for short circuit protection of induction motor using instantaneous relays. Motor connected to the source. Relays are connected in the secondary side of CTs. So I have shown these three CTs. Relays are connected in two phases only, that is in phase A and phase C. In phase B, we are not connecting any relay. Why? This I had explained in line protection, because if we use two phase fault relays and one unfault relay, they will provide the protection against all types of faults, whether it is line to ground, double line to ground, or three phase short circuit. Now let us see the salient features of this protection scheme. R1 in this phase, R1 in this phase, they are high set instantaneous relays. High set, the meaning is their pickup is high. For induction motors, we have to provide setting, that is pickup of the instantaneous relay. The pickup of the instantaneous relay should be higher than the starting current of the induction motor, because these are instantaneous relays, so they will trip as soon as current exceeds the pickup value. So it should not be less than 6 times full load current of the motor. So to be on the safer side, pickup of these instantaneous relays is selected 8 to 16 times full load current. Pickup of instantaneous relays used for short circuit protection in induction motor is from 8 to 16 times full load current. Second point is R2. These R2 are overload protective device. They can be IDMT relay or extremely inverse relay, thermal relay, or any relay having the replica characteristic. So they provide protection against overload and they act as backup protection device for instantaneous relay. This I will explain in the characteristic. R3 is also instantaneous relay connected in the residual circuit of these cities. So this takes care of earth fault. Pickup of this relay is set between 0.2 to 0.4 I full load current, because in normal condition, when supply is balanced, no current flows through this, but due to CT ratio error as well as during unbalanced power supply, some current is flowing. So to avoid the tripping of this earth fault relay during such conditions, stabilizing resistance is used. So due to this stabilizing resistance, this relay is not tripping due to CT ratio errors as well as some imbalance in the supply. So two phase fault relays for short circuit protection, two replica relays for overload protection, and one relay in the reciprocal circuit to protect against phase fault. So this is the scheme. Now let us come to the characteristic. For characteristic, we take multiple of full load current along x-axis and operating time along y-axis. With this 30 seconds straight line that is shown in the dotted shows that starting current flows for 30 seconds and overload protected device as well as short circuit protected device should not trip during this period. Now A, this represents the heating characteristic of the machine, that is thermal characteristic of the machine. B is the characteristic of overload protected device, and C is the characteristic of instantaneous relay, that is short circuit protected device. So here you can see I have selected the pickup is equal to 8 times full load current. As it is instantaneous relay, it will operate only when current exceeds 8 times full load current, and irrespective of the current magnitude, operating time will be instantaneous, that is without any intentional time delay. So this is the characteristic. Now here you can see that this overload protected device characteristic is crossing this thermal characteristic at this point, and hence it is not operating when 6 times full load current flows during starting, and it is crossing this replica, this short circuit protected device characteristic at this point. So at any time, let us say it is 10 times full load current. This is the operating time of instantaneous relay, and this is the operating time of overload protected device. So suppose instantaneous relay fails to operate, then this thermal overload protected device will provide the protection. It will operate after some time. So it is acting as backup protection for this short circuit protected device. So that is all about the short circuit protection of large induction motor by instantaneous relays. Now I will explain how small motors are protected by using fuse, MCB and MCCB. Now, protection of small induction motors by fuse and MCB. MCB oblique MCCB. Whenever I say MCB, means it is miniature circuit breaker used for small induction motors, and MCCB is multi case circuit breaker used for relatively higher HP induction motors. So here I will explain MCB, its characteristic. Same theory will be applicable for MCCB also. First, let us see construction of this MCB, miniature circuit breaker. It consists of 4 components. First is bimetallic link. It is not bimetallic link, it is bimetallic strip. So this is bimetallic strip. Here you can see that there are 2 strips connected together like this. Second is coil. On this bimetallic strip there is coil. Third is operating link. This is operating link. In normal condition it is connected to this bimetallic strip, and when it bends, it will shift in this direction. So I have shown the direction. In this arrow direction, it will shift this bimetallic link, this operating link will move. And fourth is NC contact. This is normally closed contact. So this bimetallic strip is closing this contact. So under normal condition, this is the phase. Current flows through the coil, through this normally closed contact, comes to motor and goes back to neutral. So induction motor is operating. Now let us come to the characteristic of this MCB. Here I have shown heating characteristic of the motor, that is represented by A. As usual, it is inverse characteristic. Now this MCB characteristic has 2 parts. One for the overload range and second is for short circuit range. So in the yellow I have shown the characteristic of MCB. So you can see here it is inverse, and it is inverse up to 6 times full load, up to 8 times full load current of the motor, and after that it becomes instantaneous since there is jump. So inverse characteristic up to 8 times full load current of the motor, then it is instantaneous characteristic. So up to this point it is overload range, after that it is short circuit range. It means it is 2 in 1. It provides overload protection as well as short circuit protection. Now let us see how it operates. In normal condition, when current is not exceeding the full load current of the motor, it remains intact. Now when current starts going beyond the full load current, that is overloading starts, its heating characteristic of this bimetallic strip is nothing but the replica relay characteristic. So then the strip starts bending like this, slowly it is bending. As the current increases, it starts bending more. And this bending moment depends on the amount of overload as well as time for which it is flowing. So when overload exceeds the predetermined value, then it will come like this, and this link will open. This link will open the contact. So supply to the motor will be interrupted. That is how it provides short circuit protection. If there is, this is how it provides overload protection. And when short circuit occurs, current is very high, so it bends very fast and opens this contact. So this is instantaneous. So in this way, this MCB is providing overload protection as well as short circuit protection. Now if you consider the fuse, it is used for short circuit protection only. Now we will explain the characteristic of the fuse and how this characteristic is coordinated, how the characteristic of the fuse is coordinated with that of MCB. Now I will explain short circuit protection of induction motors by HRC fuse. HRC means high rupture capacity fuse. This fuse is used as primary protection for the short circuit for small induction motors. It also acts as backup protection against short circuit when we are using MCB, MCCB or contactor for starting the motor and providing the overload protection. What is fuse? Definition is fuse, a small piece of metal which melts when current exceeds certain predetermined value. Suppose we are using 25 amperes fuse, then if current exceeds 25 amperes, then this fuse will melt. It is small piece of metal. It is connected in series with the phase in neutral also. So it melts when current exceeds its rating. That is, if rating is 25 amperes, then if current exceeds 25 amperes rating, then it will melt. Now it melts because heat generated is more. So heating characteristic of the fuse is I square T, where I is the current. Now from this equation, it is clear that the heating characteristic of the fuse also matches the heating characteristic of the machine. Now when we are using fuse, we have to match the characteristic of the fuse with the starting characteristic of the machine, as well as we have to coordinate the characteristic of the fuse with that of the primary protective device, that is MCB or MCCB, because we are discussing the protection of small induction motors. So we are using MCB or MCCB as primary protection, that is as short circuit protective device as well as overload protective device. I had explained just now that when we are using MCB or MCCB, it acts as overload protective device as well as short circuit protective device. So first, let us see how the characteristic of the fuse is matched with the starting characteristic. So for starting characteristic, we are taking time along x-axis in seconds and multiple of full load currents along y-axis. So this is the starting characteristic of the machine. 6 times full load current flows approximately for 30 seconds, then current becomes normal. So our requirement is the fuse should not melt, should not blow when starting current of 6 times full load current is flowing. So you can see here the operating time, there is difference between this. So 6 times full load current is here operating, it flows for 30 seconds. So for 30 seconds operation, the current required for the fuse is higher than 6 times full load current. So this is inverse characteristic and this is the characteristic of the fuse. You can see here when current is 8 times full load current, then this fuse operates in this time. If current increases beyond 8 times full load current, its operating time is reducing. So its characteristic is inverse characteristic. In this diagram, I have shown how the characteristic of HRC fuse is coordinated with that of the MCB. We know that both the characteristics are inverse in nature. Now when we are saying fuse, it has some rated current. Rated current means the fuse blowing current, that is the current at which this fuse will melt or fuse will blow. Whereas when we say circuit breaker, MCB or MCCB, it has breaking current, means rated breaking current. So if current is less than breaking current up to, or let us say up to breaking current, if MCB or MCCB has to interrupt current up to the magnitude of breaking current, it is causing no danger or no damage to the MCB. But if current is very high, that it goes beyond the breaking current or breaking capacity, of the MCB or MCCB, it can damage the MCB. So we have to coordinate the characteristic of the fuse with MCB in such a way that if short circuit current is less than breaking current of the MCB or MCCB, then first the breaking MCB or MCCB should operate and fuse will provide the backup protection. If current is more than breaking current or breaking capacity of the MCB or MCCB, then in order to protect the MCB also, fuse should blow first, and if fuse fails to operate, then only MCB or MCCB should operate. So in this diagram, A is the characteristic of MCB and B is the characteristic of fuse. This is the breaking current or breaking capacity or current corresponding to breaking capacity of this MCB or MCCB. So these two characteristics, that is characteristic of MCB and fuse, they are intersecting at this breaking current point. So if current is less than breaking current or breaking capacity of this MCB, then operating time of MCB is less than operating time of fuse. You can see here, if we consider this current I1, this is the operating time of fuse, and this is the operating time of MCB. So operating time of MCB is less than that of the fuse. If current is more than breaking current, say I2, then operating time of fuse should be less than operating time of MCB. You can see here, for this current I2, this is the operating time of MCB and this is the operating time of fuse. So operating time of fuse is less than operating time of MCB or MCCB. So in this way, the characteristic of fuse and MCB, they are coordinated when both are used as short circuit protection for the small induction motor, and in that case MCB is providing dual protection, that is overload protection as well as short circuit protection. So that is all about short circuit protection, coordination of overload characteristic, overload protective device characteristic, and characteristic of short circuit protective device for induction motors. Friends, if you feel this video lecture useful, then please like it, subscribe to my channel, ask your friends, colleagues and juniors to subscribe to my channel for upcoming video lectures on power system protection and high voltage engineering. If you want to make effective and efficient use of time, then read my book on time management. The link for the book is given in the description box. If you want to improve your learning capability, read my book on this learning ability, that is how to accelerate your learning power by using power of subconscious mind. The link for the book is given in the description box. This book is available, so it is not book, it is course. If you want to excel in competitive exam as well as in other exams, then join my course on Udemy. The link for the course is also given in the description box. Thank you.